In today's video, I have brought you a very nice problem. Here is the following statement. We have for all x and n as a natural number associated with a prime p. Here is the first problem. Satisfy this equation. We have x to the x minus number 1 equals p to the n. So the second problem, the only difference between first and second problem, only the minus sign. First problem has the minus sign, the second problem has a plus sign. So I'm going to do just the first problem. I will leave the second problem to you guys. Just let me know in the comment section below. So let's get into the solution. So here is the following equation. We have x to the x minus number 1 equals p to the n. Okay. As you know, we are going to discuss two cases because prime number could be even or odd. Okay. Let's assume if p is even. If p is even, which means p equals 2. I'm simply going to take that value of p and insert it into this equation to see what's the status of this equation. X to the x minus number 1 equals 2 to the n. Okay. We know the right side of this equation is even because it's power of 2. So that means the left hand side of this equation must be even. Okay. So since we have minus number 1 here, which means x to the x is an odd. In the other word, x is an odd. Okay. X must be odd. If x is an odd, let's set x equals to a plus number 1. Okay. But we have x to the x, which means I get x to the x equals 2 to the a plus number 1, or to a plus number 1 as an exponent. Okay. This expression will be written on the form of x to the x. This expression it will be number 2a plus number 1 is multiplied by 2 to the a plus number 1 to the a square, like this. Okay. So what I have done here, I just take in this number 1. It was 2a plus number 1, because if you multiply 2a plus number 1 by this one, is going to be on this form, 2 to a plus number 1. Okay. So by taking this number 2 as an exponent, let's set all this term is z. Okay, including the a as an exponent. So which means I will have 2a plus number 1 is multiplied by z square. Okay, like this, minus number 1 equals 2 to the n, like this. Okay. Now I'm simply going to move over minus 1 to the right. I get here 2a plus number 1 z square equals 2n plus number 1. Okay. Now we'll have two cases. If n is an even, this one becomes non-factorable polynomial. We cannot factor out this one since we have the plus sign and n is an even. Okay, which means I will have only one term here. But the left hand side of this equation is already factorized into two terms. We have z square, we have 2a plus number 1. Which means one of the term is going to take number 1. Which one is going to take number 1? Smallest one. Which one is the small here? Is 2a plus number 1, because z square is bigger than this one. If 2a plus number 1 is going to take number 1. Okay. So this one is telling us is a equals 0. Okay. If a equals 0, by going back to this setup here, I get here 0, I get 1, I get 0. So which means x to the x equals 1. In the other word, x equals 1. If x equals 1, I'm going to take this value of x and insert it back into the original equation. Which means I get here 1 minus 1, which is 0. 0 equals 2 to the n, which is impossible to have 0 equals 2 to the n. Okay? Since we have n is a natural number. Okay? So this one, it's clearly, it's a contradiction. It's impossible. Okay? Which means this case it's impossible. Now let's move on. If n is an odd, if n is an odd, this one becomes factorable polynomial because we have odd here, which means we are allowed to factor out this one on the form of the product. So I will have the following. I will have 2a plus number 1 is multiplied by z square. 2 to the n plus number 1 becomes 2 plus number 1 factor 2 to the n minus 1 minus 2 to the n minus 2, the other one is plus 2 to the n minus 3 minus, and all the way down to the number 1, like this. Okay, so this is number 3 here. Now we are going to make the comparison, which one is a bigger, which one is smaller. So we already found this one is a smaller than this one, which the right hand side of this equation has a multiple of 3. So now we are going to make a nice comparison here in order to determine A and to see this equation is accepting the solutions or no. Okay, so now since this one is odd, this term is odd, the right hand side of this equation also is odd, this term is odd, this term is odd. So now I'm simple when it comes to the comparison here. So number 3 is going to take one of these numbers. Number 3 can be 2a plus number 1, it can be 2a plus number 1 to the a, it can be 2a plus number 1 to the a square, it can be this product, the whole thing. 2a plus number 1 is multiplied by the whole thing. Okay, so we will have two things here. So if a equal to 0, I will have the same thing. The whole term is going to is the same as the first term, the second term, third on the fourth term, because replacing a with 0, the everything turns into 1 here. Okay, whatever the number you take, either this one, or you can square it, because a equals 0 is make this one equals 1. If a equals 0, I'm going to replace 0 here, I get x equals 1. If x equals 1, by going back to the original equation, I get 1 minus 1, which is 0. So we'll have 0 equals 2 to the n, which is clearly it's impossible. Okay, this one it's happened when we have a equals 0. Okay, all a is super equal to 1. Okay, because as a is growing up, this value is become more bigger than 3. Okay, so which means this one is telling us number 3 is going to take number 2a plus number 1. Okay, so all other stuff is going to be this one. Okay, we don't care about this one because we don't even know this value of this one, because they have a bunch of the terms, so we don't care about it. So this one is clearly, if you calculate, this one is giving us a equals 1. Okay, as we just said, now if a is greater than 1, it's clearly it's impossible, because this number 2a plus number 1 is going to exceed number 3 here. Okay, let's take this value of a and insert it into this equation to find x. Okay, this equation, it was x to the x minus number 1 equals 2 to the n, because p was replaced with number 2 as a even prime. Okay, now let's take this value of a, which equals 1, and insert it in the above equation to find x. If a equals 1 here, I get here 2 plus 1, which is 3. The exponent I get 2 is multiplied by 1 is 2 plus 1, which is 3. I will have x to the x, I will have x to the x equals 3 to the 3, which is 27, which equals 2 to the n plus number 1. Okay, now I'm going to move over number 1 to the left. I get here 27 minus 1, which is 26, 2 to the 5, which is 32, minus 6, because we have 32 minus 26 given us 6, equals 2 to the n. Okay, so this value, it's clearly it's impossible, because the right hand side of this equation is a power of 2, which means the left hand side of this equation is not the power of 2. Okay, which means we have no solutions for the equation for both when we have n is even and n is odd. So what we have constructed here, we have constructed the parity of the prime. This is not even prime, is a odd prime, which means p must be super equal to 3. Now let's take this one and discuss it in the next case when we have p as an odd prime. Okay, so this case is different than previous case. So the parity of x, it was odd in the previous case. Now x becomes even because of this prime, because we have p as an odd prime. Okay, since we know x is a even, because we have even minus odd is given as odd. Okay, so if x is a even, let's set x equals to a. Okay, but we have x to the x, which means I will have x to the x equals 2a to the 2a, like this. Then I'm going to use a small trick here. I'm going to put this one on the form of 2 to the a is multiplied by e to the a, all is raised to the power 2. Okay, then I'm going to take this value and put it as a z. by putting the substitution. Okay, so now I'm simply going to take this z and insert it into above equation. Here z squared minus number 1 equals p to the n. Okay, previously we knew the value of p because it was even. Now the problem, we don't know the value of p as a odd prime. Okay, now but the nice thing here, I have a nice factorization here. This one will be written on the form of the product. So which means, since I have the right side of this equation is a power of p, that means the left hand side of this equation must be a power of p as well. Okay, so now let's go through this one. I will have z minus 1 factor z plus number 1 equals p to the n. Another nice thing here, the GCD of these two terms equals 1 because you have the consecutive odd integers. Okay, because z is an even, so this one is an odd, this one also is an odd. Okay, now we found the GCD equals 1 because we have the consecutive odd integers. GCD equals 1 is not going to help us here because since we have the right hand side of this equation is a power of p, which means the left hand side of this equation is a power of t as well here. So now this one becomes on the form of the equation system because since we have the power of p here, so I will mean, which means I will have z minus 1 equals p to the I, and z plus number 1 is going to be p to the j, where is g is strictly superior than I because this term is bigger than this term. Okay, now I'm simply going to make this equation minus this equation. I get here 1 minus minus 2, which is 2. Here z will be cancelled out. I get here p to the j minus p to the I. Since this one is smaller than this one, I'm going to take it as a common factor. We'll have p to the I factor p to the j minus I minus number 1. Okay, now it's very clear here. This odd, we don't have the odd number on the left, so the only odd we have is this number 1, which means I is going to take number 0 here. If the exponent equal to 0, which means p to the I is equal to 1. Okay, so this one is clearly going to take number 2 here. Okay, so we'll have p to the j, I is going to take number 0 minus 1 equals 2. So this is equivalent p to the j equals 3. The exponent is 1, which means g equals 1. I'm simply going to take this value of g and insert it into above equation here. G it will be 1, p to the I will be 0 here, which means the whole thing equals 1. So I'm simply going to extract z from here. I will have z equals 1 plus 1, which is 2. Now I found the value of z. I found z equals 2. I found p as a prime number equals 3. So I got two values. Now it's very easy to find x. I will have x to the x, which equals z squared, 2 square, which is 4. This one is telling us x equals 2. Okay, if x equals 2, which means x to the x equals 4. If x to the x equals 4, which means 4 minus 1 equals 3 to the n, because we found p equals 3. This one equals 3. 4 minus 1 is 3. The exponent here equals 1. Okay, now I will have the pair of the solution is going to be x equals 2 and p equals 3 with n equals 1. Okay, I'm going to leave this one to you guys. Let me know in the comment section below. So this one is different than this one because this plus sign makes everything totally different than above one. Okay, next we may do it in next time because now I don't want to make the video too long. So I have undo this video. So by the way, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.